Hello, everybody. So what we're going to be looking at today is assignment 4. Let me redo my web browser here. Okay, so where were we? I think in the previous lecture, which was a makeup for the lecture that was recorded with no audio, what we did was the following. So you start out with this function, Euler, which calls a bunch of other functions, make circuit, remove edges, find vertex, merge circuit. So it calls four other functions, and you have to write those four. And so in the previous lecture, we wrote two of those. So if I go over to Octave here to see where we are, hold on, there's Octave. We've got make circuit right here and remove edges right here. We're missing Euler. Let's just make an Euler right here since we can just copy paste it. Maybe. You always have to be careful copy pasting from a PDF like this, but we can just eyeball it and see if it looks okay. I think it'll be okay. And then that. Save. Euler.in. Oops. Euler.m. There we go. So this is where we left off. So we have this Euler function. We have make circuit, which we wrote twice. And we have remove edges, which we wrote once. And we tested all these and they work. Well, we tested the two that we wrote. We didn't test Euler. Euler was given to you. Okay, so what we need to do today is we need to write the other two functions, which I don't know. I mean, probably it'll end up appearing on the screen, but my intention is not to write these completely for you. You should be able to do it on your own. So let's look here. So what did we do? We did A and B. A is make circuit. B is remove edges. C is find vertex. So let's copy paste this and then we'll look at what it's supposed to do. Come on. Copy. Octave. Let's make a new file. Paste that in. And let's look at what this function is supposed to do. So if I open a notepad to type in, get a new window, and let's type a little bit. So what is this function supposed to do? So find vertex is got a very simple job to do. So it tells you that you have two input variables, the edges for G, the edges for H, two different graphs. And you're going to know, that they have at least one vertex in common, and we need to find it. Okay, so it says this right here. What we need to return are, well, the vertex that we found that's in both lists and the position in the edge list, e.g., that contains V. Okay, so what does that mean? What that means is the following. So suppose our edges for G, which I'm just going to call them G this time, looks like this. So this is just a made up example. 1, 2, we'll do this. 1, 2, 2, oops, 3, 3, 4, let's say 4, 7, 7, 2, that's a 3, that's fine. 1, 6, 5, 6. Okay, what's the point? The point is this is just a graph, okay? And if I make another graph, and this graph will be H, this is going to have its own vertex list, edge list. Could have anything that we want in there. So like, let's say 4, 5, 4, 6, 7, 4, 5, 2, 3, 1. Okay, that's fine. It just needs to be a list. Okay, and so all this function is supposed to do is the following. So suppose we called this. So like we define this at the command prompt and we define this at the command prompt. And then we type find vertex G H, right? What is the answer supposed to be? So the answer is supposed to be two things. The first thing, oh, sorry. Yeah, no, that's fine. Um, Let me actually, yeah, no, that's fine. That's fine. Let me just delete a couple of these just to make it more obvious what's going on. Yeah, okay. So what's supposed to happen here? So you call FindVertex H. What it's supposed to do is find a vertex in common. It doesn't matter what vertex. So like if you look at these two lists right here, and you just can look at them one by one. So like there's a 1 in G. There's no 1 in H. So they don't have a 1 in common. So you look at the 2. There's a 2 in G. Is there a 2 in H? No. 2. Well, we already looked at 2. So look at 3. Is there a 3 in H? No, there's no 3 in H. So you go look for 3 again. Don't find it. Look for a 4. There's a 4 in G and there's a 4 in H. Okay. So V is the number of the vertex that both edge lists have. So it should be returning, first of all, 4, because that's the vertex that they have in common. And then the other thing that we return is this in, which is the position in the edge list G that contains V. So when we were looking for a 4, right, where in this list did you find the 4? And it's what row you're in. So you say, is it in the first row? No. Is it in the second row? No. Is it in the third row? Yes. You found the 4 in the third row, right? So you found the 4 in the third row, and then so that should be the other thing that you return. So the first thing you return is V. That's the vertex that they have in common, right? You can see it highlighted. G has 4s, H has 4s. And then the 3 is what row you found it in G. Okay? And so when I say position, the position is just what row. You don't have to say like first or second position. That doesn't matter, just what row you're in. Okay, and that's all that FindVertex needs to do. And so all you need to do really is just loop through G and H and just compare every component until you find one that matches, and then you return basically. So it's actually a pretty simple function. And there's probably pseudocode. If I look in my web browser, you can find some pseudocode. And what's this? Wait, did I write the whole thing? Hold on. Terrible things have happened. Oh, no. Okay, sorry. I was confused. I was like, oh, I wrote the whole thing. No, I wrote the pseudocode for the whole thing. I didn't write the whole code, right? Because this is pseudocode. Yeah, so let's see if we can look at this side by side with Octave here. I've got lots of crap open, don't I? All right. So let's look at it. So what we want to do is translate this pseudocode to Matlab code. This is not Matlab, right? So when you're looking at this document to try to write the code, make sure you understand that my intention was not to write Matlab code. My intention was to copy the book's pseudocode syntax. So like this line right here, notice that the way it goes colon equals, that's how they say equality. That means set EG equal to this. That's how they do it in the book. That's not how you do it in MATLAB code, okay? So same thing with the V in the end. So all those need to be fixed, and things like it says like number of rows in EG, that needs to be fixed, and so on. So let's go ahead and get started here. We're just going to try to go through this pseudocode here. So it says to start out with, V should be 0, N should be 0. So we initialize these to 0. Why do we initialize them to 0? Because if we don't find something in common, we're just going to return zeros, right? We're supposed to have we're supposed to find a vertex in common between the two lists, but if we don't find it, we want to return a 0. So start there. Now then we've got a for loop, it says. For I equals 1 to the number of rows in EG. For I equals 1 to the number of rows of EG. So what is that? Like rows of EG maybe? But the problem with that is this does not exist. We're going to have to figure out what the number of rows is of EG, but we can do that. Go on to the next thing. EG is EGI comma colon. So let's do this. EG equals EG I comma colon. So the uppercase variable is all of the edges in a list, and little eg is just one edge. So that's what we're doing here. What else can I say about this? Yeah, so let me make a list here. So we'll copy this from here. Let's just take one of these. All right, so like there's a list of EG, and EG in this case has 1, 2, 3, 4, 5, 6, 7 rows. So like if I go for I equals 1 to 7, you're not supposed to type this in the command prompt, but I am. Let's do little eg equals eg I comma colon, and then end. And I left the semicolon off it so we could see what the output was. So hopefully you can see what it did. Why can't I scroll up? Come on. You know, sometimes Octave is annoying compared to Matlab. What was EG? Let me look at it. EG real quick. There it is. So hopefully you can see what it did was every time through the loop, it was assigning the little eg to be one row, right? Like 4, 7, 4, 7, 7, 3, 7, 3. 1, 6, 1, 6. And so we're just pulling out one edge at a time. You don't have to do that, but it makes the code nicer, some of the code that comes later. All right. Now what's next? Now we do another for loop. We're going to loop through the edges of H. So we're looping through the edges of rows, EH. We're looping through the rows of EG, and we're looping through the rows of EH. And we're doing that because, remember, you have to compare everything in here to everything in here. That's what we're trying to do. So we're looking for what's in common, right? And as soon as we find something in common, we're done. We don't need to know all of the vertices that are in common. We just need to know one. So we're going to loop through EG and loop through EH, nested loops. Okay, now what? All right, so we're going to pull out EH. We're going to pull out an edge from EH exactly the same way that we pulled an edge out of EG. So at this point, right, EG and EH are, one edge from EG and one from EH. So we've got one edge from each right now. And then what are we going to do with them? Well, what we're going to do with them is we need to compare them. And so you can see the comparison here in this block of code. And what it is we're going to compare the first components, right? So if you have two edges here, right? Like let's say little eg is like 3, 5. And let's say little EH is, I don't know, let's say 1, 5. Okay, so what we need to do is at this point, we need to know, are either of these numbers equal to either of these numbers? So there's actually 4 comparisons to make. You have to compare first component here to first component here, then first component to second component, and then second component to first component, and then second component to second component, right? So first to first, second to second, first to second, second to first. 4 comparisons. And that's what this shows. So like EG1, EH1, EG1, EH2, EG2, EH1, EG2, EH2. You see? And then in each case, we're going to do something. Okay, so you do not have to do this with for if statements. There's other ways to do it, but you can do it with for if statements. So that's just how I wrote the pseudocode. So that's how we'll do it here. So let's say if EG1 equals, which this is a test for equality, so it's not equals, it's equals EH1, so then what do we do? And that's where you have to think about what the mission statement for this function is. Okay, so we're looking for when things match up, right? So if the first components match, this component and this component, right? We compare this to this and they matched, which is generally not going to happen, right? There's 4 comparisons, so sometimes the first will match the first and sometimes it won't. What you're supposed to do is the following, right? V is the number of the vertex that both edge lists have. So if EG1 equals EH1, these are the same number, and that number is what V is supposed to be. So you just go V equals EG1. You could also say EH1, and that would also be correct because they're the same number. Okay, so that's what V would be. And then N is going to be the position in the edge list EG that contains V. And remember why that is if we look here, like remember how this is going to go. When you find something that matches, right? So like we find the 4, and that's in both of these lists. The N is actually going to be what row in G are we in? First row, second row, third row. So that's position 3. So N is 3 in this case, right? That's what we wrote here, down here. So you need to know what N is supposed to be is what row we're in G. So if you look at these for loops, the current row of EH is J, right? J is looping through the rows of H. I is looping through the rows of G. So I is the row that we're in. So you do that. And also, this function here, as soon as it finds something that matches, which we just did, right, in this block of code, then you're done with the entire function. So the way that you deal with that is you just say, okay, well, we don't need to do anything else. We should just return. That's it. Okay, and then that is the entire thing you need to do in order to test first position and first position. And if you look at what we're doing here, you just redo this 4 different times where you change the ones to different things, right? 1, 1, 1, 1, 2, 1, 2, 1, 2, 2, 2, 2. And the reason the one down here always matches whatever is in EG, right? EG2, 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 EG1, EG1. Okay, so we just need this block of code 4 times. So we got it once, twice, 3 times, 4 times. So we have it 4 times, and then let's just change the numbers. So 1, 1, 1, 1, 2, 1, that's correct. Then 2, 1, 2, and then 2, 2, 2. And that's where the pseudocode ends, because pseudocode, they don't use end statements. They just end when they want to end. So what have we ended? So each if statement has an if and an end, if and an end, if and an end, if and an end. So the if statements are all done, but this for loop needs an end statement. And also this for loop needs an end statement as well. So there we go. So we ended both for loops on lines 36 and 37, and we ended all of the 4 if statements. So you would think that we're done. I'm going to save this. FindVertex.m. Save. And it will not run. Right. So like if I do eg equals, let's take the other one here. All right, if I try it, find vertex g h. Of course, what they call? I call them eg and eh. Of course, it gives me an error, right? Rows eg undefined. And if you look back at the code, it's obvious why. It's because there is no variable rows eg and there is no variable rows eh. We have to calculate those. And hopefully you remember how to do this. It's a 2-step process. So like remember, like if you're looking at eg and you need to know the number of rows, what you want to do is first you do like, I don't know, like s equals size eg. You get this 2-component vector back, 7, 2, and 7 is the number of rows. So then you would do like rows eg equals first component of the size. And then you would have the correct thing there. So you need a size and then a separate command. So 2 lines to get that number of rows. So how could we do it? Well, just like what I wrote, right? S equals size of g, and then rows eg is first component of that size. But we also have rows eh, so we need to do that again. I can reuse the variable s, it doesn't matter. And then just change those g's to h's. And so at this point, now both of these should have the correct value and our code should run. So let's try it. EH undefined, line 21. Ah. Did I copy paste this or did I type it? Terrible. Wait. That was equal EH equals EHJ and EG equals EGI. Okay, try again. Oh, lots of stuff on the screen. Where are my semicolons missing? Right there. Anywhere else? Nope. So I'll save it. Try to run it again. There we go. 4. Now, something that you may find confusing here is it just says 4, right? And we know when we looked at the notepad here, right? The answer should be 4, 3, right? 4 is the vertex that it found in common. 3 is the row. And so you get confused at first, right? You say, oh, well, we got the 4, where's the 3? And if you look here, you say, did I forget the return variable? No, it's in, and we assign in, right? All 4 cases have an in. So it seems like everything's fine here. But you have to remember, there's something weird about the way Matlab works. When you have a function that returns 2 variables, like this one returns 2 variables, you only see the first one, in this case v, unless you ask Matlab to save both of them. And the way you would do that is you have to give it a place to put it. So you'd have to type something like this: v in equals find vertex eg, eh. And then now that I give it 2 variables, it can store the 4 for the v and it can store the 3 for the n, assuming that it works correctly. Let's see. There you go. So v is 4, n is 3. That's perfect. That's the way it's supposed to work. We can try it with the sample code from the other PDF, right? It's supposed to work like this. Let's look at this for a second before we run it. So if you look at this and say, well, what should it find in common? It should probably find a 4, right? Because just going down the list of G, H, and you say, well, what are the first things you see that they have in common, right? There's a 1 in G, but no 1 in H. There's a 2 in G, no 2 in H. There's a 1 in G, no 1 in H. There's a 4 in G. Oh, look, there's a 4. There's a 4 right there in H. So when we run this, the V should be 4. And the N, which is what row you're in where you find the 4, should actually be a 2, right? This is going to be the first row, and this is going to be the second row, and the 4 is in the second row. So 4, 2 is what this should return. So copy it, paste it. Let's see. Yeah, 4, 2. Perfect. Okay. So our FindVertex appears to be working correctly. What next? Last thing, MergeCircuits. So MergeCircuits seems complicated. And probably if you look at the pseudocode's probably complicated too. Actually, I guess it's not that bad. No, I guess it's really not that bad because I essentially wrote it all for us, didn't I? Okay, sure. So let's write it. Editor, we need a new function. Our function is called MergeCircuits. What's the return variable? I think new circuit is the return variable. And the name is MergeCircuits. And the input is, I believe, circuit and subcircuit. And, you know, you don't have to use my variable names, but these are the ones I typed it up with. So I will stick with them, even if it's extra typing. Okay, so there's my function. And again, we got pseudocode here. So basically, we just need to do this, but we need to make it Matlab code. So let's do that. So we're just going to copy it line by line here. New circuit should be empty. New circuit should be empty, right? Close brackets with nothing in it, empty vector. All right, now we need the number of rows of circuit and the number of rows of subcircuit. Well, we know how to do that, right? Because we just did it here, right, with this code. So I'm just going to copy this, come back over here, paste it, but then the names are wrong here, right? So first we should be doing the rows of circuit, and I'll call it, what are we supposed to call it? In capital C. Okay. Oh, there's a typo. See it. Okay. Anyway, then we need the number of rows of subcircuit, which, okay, let's be careful here. Let me look at the other function. No, sorry, the other file. Whoa. All right, so the way I wrote it, I have a capital C on that subcircuit. That's fine, just you have to be consistent, right? So put a capital C there. So then this is going to be the size of the subcircuit, and then this is going to be in S. All right, so we have those. Let's go back to the other document for the pseudocode. Here we are, and then we got this. And it looks like I couldn't help myself because this is Matlab code, almost Matlab code. I'm going to copy it and then paste it, and then we'll fix it because there's going to be a problem here. Okay. So this is fine. The problem with it is right here, right? Colon equals. That's not how you do equal. Like, sorry, that's not how you set something equal in MATLAB. So these colons are extra. And I'm going to save this as merge circuits, and then we're going to stop and we're going to talk about how it's supposed to work because first of all, I see a bug. I see this in here that's not defined, so we got to fix that. And then also let's figure out what it should be by trying to look at the code. Oh wait, no, I know what in should be because I've zoomed in too far. Scroll right. In is the input variable or an input variable. Okay, there's the in. Okay, so I mean, this is just the code. This is the pseudocode exactly how it's written, just fixing the equal signs to be regular equal signs. So who knows, maybe this actually works, but let's talk about why or how it's supposed to work. Okay, so here's how it's supposed to work. So you have circuit, like let's say, I'm just going to call them C and SC. So like, let's say your circuit is just 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 1. Okay, that's a circuit. Now let's say my sub-circuit, which I'm going to call it SC, is similarly defined. Let's say it is 5, 2, I wrote a 3, 3, 1, 3, 1, 1, 5. Okay, so like let's say that's what we have here. Okay, now what you're going to do is, or not you're going to do it, but what the Euler function does is it calls the function like this. So it's going to call, like let's say NC for new circuit is going to be merge circuits. And it's going to call merge circuits with the C, the SC, the subcircuit, and an N. And it's going to have the right N. And the N is going to be what row we want to put SC in. So SC, you can see that the subcircuit here, 5, 3, 3, 1, 1, 5. If you remember how circuits work, this is a list of edges that goes from 5 to 3, from 3 to 1, and from 1 to 5, right? So this circuit starts and stops at 5. And if you look in this list for the 5, 1, 2, 2, 3, 3, 4, 4, 5, the 5 is right here, right? 5 is here. In row, what's the row? 1, 2, 3, 4. Row 4. Okay. Now, how would you find that? How are you gonna find that number? Well, that number you're gonna get from that FindVertex function, right? That's why we wrote this FindVertex function, so that you would be able to calculate this, right? You would look at these two. You would look at these two things, and you would say, "Oh, they have a 5 in common." Okay, so that's where that number will come from. It doesn't come like directly like that, but that's the idea. So in this case, we found the 5 is in row 4. So when this gets called, it would be called with a 4. You don't have to decide that. That's just the number that will end up there. And then what is it supposed to do? So what MergeCircuits is supposed to do is this. So if you have a 4 here, you're supposed to take the first 4 rows from C. So you would have first 4 rows from the circuit. Okay? So that much. After you do the first 4 rows of circuit, then you want all of the subcircuit. All of the subcircuit. So that's this. And then finally, you did the first 4 rows from circuit. Now you want the rest of circuit, which we're calling C here, right? So what does that mean? It means that what gets returned here for your new circuit is supposed to be the following. 4 rows from C, 1, 2, 3, 4. Okay. Then all of the subcircuit, which is those 3 rows. Maybe I'll add a little separator here. See it? And then after you do that, then you want whatever's left from C, which is this much. No, sorry. This much. Last 2 rows. And then that would be the end. Okay. And again, you don't have to worry about like, where does this 4 come from when you're writing merge circuits. Whoever's calling merge circuits knows that 4 is the correct number. Okay. So that's the idea. So if you look at the code here, pseudocode here, you can see that it does just exactly this. So let me move this over a little bit. Okay, there we go. Right, so in would be where that 4 is coming in. And so this right here is, it's gonna go, I goes from 1 to n, like in this 4. And what this is gonna do is it's gonna loop through here, copying 4 rows into new circuit. Okay, there you go. And then, so that does that much. Then you have another for loop. And this for loop right here, you can see you have your new circuit and it's copying the subcircuit into the new circuit. So that would copy the middle block, all of SC. And then last bit, another for loop. This is going to calculate the last little bit of circuit and copy that into the new circuit. And the indices are set up for that. So like, if you look here, this is 1 to n. And this last one is n plus 1 to whatever the end of the length of NC, the length of C. Right? So the first one C, the last one C, and the middle one is the subcircuit. So C, subcircuit in the middle. And so that's all this does here. There's, much more concise ways to do it in Matlab. Let's just save this and just see if it works. Actually, let's run it with this code because I just typed it up. That C. There's C. Actually, you know what? I'm changing my mind. Let's make it like really easy to, let's make it really easy to see. So I'm going to make C all ones. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Very nice. Now let's make S, I guess SC, and let's make it all 9s or something. 9, 9, 9, 9, 9, 9, 9, 9. There you go. So let's see what MergeCircuits does. So we have C, we have SC, and then we need a position. So how about for the position, let's go with like 3. I wrote 1 to n, colon, 1 to n. We have to write Matlab code, not pseudocode. Okay, save that again, try it again. Okay, oops. Nope, we don't like that. Semicolons on everything. Okay, everything with a semicolon, try again. Okay, there we go. So you can see what happened here, right? So you have 3 rows from C, which was all 1s. Then you have all 9s, that's the subcircuit, the SC. And then you have a bunch of 1s, that's the rest of C. So it stuck the subcircuit here in the middle of all these ones. And where does it put it? Well, when you put a 3 in here, it's 3 rows and then SC. 3 rows of C, then SC, and then the rest of C. And you can check that this works with other numbers here. Like if I put like a 1, should be after the first row, and it is. If I put like a 0, which actually would never run in Euler, the way Euler works, but if you put a 0 in, it comes at the beginning. If you put, okay, well, how big is, well, I don't know, hold on. If I put a 6, it's after row 6. If I put a 7, it's after row 7. Now, does something weird happen if I put an 8? Yeah, there's an error. Right, you can't do 8 rows because you would have all of C, but C only has 7 rows. 1, 2, 3, 4, 5, 6, 7. Yeah, so there's no 8 rows, so you can't call it there. But that's fine. It never will get called with a number bigger than the number of things in the array. So yeah, so this looks like it works. Now I'm going to make another version of this just to show you that there's lots, fancier ways to do it. Let's call this MergeCircuits 2. Save. You don't need to do that, of course. Just making another version of this. So if you delete all these if statements here, then and even this, let's get rid of the sizes as well. And even the new circuit, everything goes away. So let's think about this. So like, suppose you have, let's again look at C and then S. Oh, no, sorry. C and then SC. Okay. So like, how would you copy like 3 rows out of this? You could say C, and then you know that there's like 2 components here, right? And when you call this, so like if I do like 1, 1, then I'm going to get the upper left-hand corner 1, right? That's position 1, 1. But you can use placeholders. So like if you want 3 rows, this would give you 3 rows right here. So what this syntax does is this says rows 1 through 3, and the colon by itself says every column. So 3 rows, every column, and there's 2 columns. So 3 rows, 2 columns. And there they are, right? So if you're trying to make new circuit, well, you could say it's just going to be circuit 1 to n, comma, colon. That's how you get the first n rows. And then you're supposed to have, like after you do the rows of C, you need all of SC. All of SC, of course, is just SC by itself. So you go semicolon subcircuit. Or here, right? If we do this, semicolon SC. So there's 3 rows and then all of SC. Over here, this would be in rows and then all of SC. And then somehow you need to put the rest of the circuit at the end. So what you would do is pretty much the same as this first block, C, but instead of, if this went from 1 to 3, you would need to start this at a 4. You can go to the end, which you can just call end. You don't have to know how many things are in how many rows. And then colon again for every column. And so one line like this actually does the entire thing. So we just need the equivalent of this line right here in the code for MergeCircuits. So it's called circuit, and it's not 4. 4 is n plus 1, right? So this function here could just be a single line function. And so if I call merge circuit, oops, with like a 5, right? Or if I call merge circuits 2, same answer. Do I get the same error if I go to 8? Yes. Does it still work with a 0? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just making sure we didn't skip a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So even though my pseudocode was pretty complicated here, if you know about how Matlab deal with indices for lists, then you could actually write this in one line, and of course that's nicer. All right, so I think that's pretty much it. Let's test this now. So I don't have this graph drawn out, but this is a graph. I'm gonna just go to the command window. There's a graph, okay? And we're supposed to be looking for an Euler circuit. So we've talked about how to find Euler circuits before. We're not going to talk about it right now, but let's just look at the output of Euler. Hopefully Euler runs, and we can see if that is in fact an Euler circuit. Okay, so here's what Euler did. First of all, I could have used some extra semicolons on stuff. Oh, something is missing semicolons. Well, make circuit. Sorry, just I don't like it when remove edges. Run it again. Okay, there we go. I just don't like it when it's spamming the console window like that. So let's look at the output here to see if we actually found an Euler circuit. So our original G was this. And this represents a graph. You can draw the graph, but I'm not going to. And then our circuit why can't I spell circuit? Is supposed to be what we have here. Oh no. What we have here. This is supposed to be an Euler circuit. Now, what is an Euler circuit? Remember, an Euler circuit is supposed to use all of the edges of G, so count the edges. So G had 1, 2, 3, 4, 5, 6, 7, 8, 9 edges, and the circuit has 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. So we have the right number of edges, that's good. And the Euler circuit is supposed to use every edge, and it's a trip around the graph, right? We're using all the edges once. So what this is doing is like the first thing, like the first line up here says like vertex 1. I'm just going to write it this way, like V1 for vertex 1 to V3. That's an edge, right? That's what the first line means. And then the next one says we go V3 to V4. That's an edge. So we started at V1. We went from V1 to V3, V3 to V4. So V4 to something, V4 to V5. So now we're at vertex 5. Now the next one says 4, 5 again. So what that means is that we go from vertex 1 to 3, 3 to 4, 4 to 5. And even though it says 4, 5, they actually mean we go from vertex 5 back to vertex 4. Right? 4 to 5 and then 5 back to 4. Both of those use an edge from 4 to 5. It doesn't matter which order you write them in. So you have to sort of interpret this output here. So 4 to 5, 5 to 4. So we're here. Then 2, 4, that would mean, since we're at vertex 4 currently, when you see 2, 4, that means from 4 to 2. Right, so we're changing the order of some of these as we go to make it make sense. So we go from 4 to 2, and then from 2 to 5. and then from 5 back to 3, and then from 3 to 2, and then finally 1, 2, or the way we're interpreting it, vertex 2 to vertex 1. Okay, so we started on V1, and we did all these edges, and then we end on V1. Right, so this is an Euler circuit because all of these edges were the original edges from G up here, and so we use all of them, and we took a trip through every single edge. We only used every edge once. You can look at it to make sure. And we started at V1, and we ended at V1. So that's an Euler circuit. So we're done. Right? So we had these 4 functions to write: merge circuits, find vertex, remove edges, make circuit, Euler. And there you go. That is your homework essentially done from beginning to end. So make sure you code it up, type it up, turn it in by Friday. And yeah, so I'll talk to you guys later. Be sure to check out the next video, which is going to be on the final exam. Like review, not review, but like I'm going to work through the sample test for you guys. All right, so that's it for now. Talk to you guys later.